and good morning. My name is Rajiv, and alongside me is Audrey, Mickey, Sanjuti, and Sharab, and we are here today to present to you our Bicycle Safety Enhancement Suite. Audrey will begin the project introduction.
So as we all know, the number of bicycle commuters has been increasing in the recent years, especially in densely populated cities. But unfortunately, the safety for bicyclists is often very lacking. And a lot of products on the market for bicycle safety are either at very steep price points or very scope limited, like either an expensive bike helmet with turn signals or cheap bike reflectors. We wanted to make a more robust and expensive system that had multiple safety features, namely a blind spot detection system, turn signals, and a tail light. So Mickey will go over our project goals.
Okay, so our goal for this project is to create an affordable project with the blind spot detection, which will gonna detect and alert the rider within 4 meters, and we want the riders more noticeable with the tail light and the turning signals, and which is visible in daylight as well. And we want this system to be modular and universal to fit in any cars, and we also want this system gonna be inexpensive, and it's cost under $200, and its weight is less than 1,000 gram. And for the system overview, I'll pass over to Sanjay.
So our entire system will be split into 3 modules. First of all, the blind spot detection system that has 2 ultrasonic sensors to detect a moving car or an object, and then an LED will be illuminated on the side of the detected object on the handlebar. Secondly, an LED grid will be used to display turn signals, and it will also act as a tail light. And toggle switch on the handlebar is going to control that turn signal. And finally, our power management system includes a dynamo bicycle generator and a rechargeable battery to provide a stable power to our system. So I'm going to pass it to Shorav to talk about specifications more.
A little bit more in depth about the specifications. The system will run on 5 volts power and logic. The power will be supplied by a 3.7 volt rechargeable LiPo battery, which will be boosted by the Adafruit Power Boost 1000. And due to its load sharing capabilities, we can also charge the battery from our bicycle dynamo generator. The microcontroller we chose for this project is the Adafruit Itsy Bitsy, primarily due to its very lightweight. It's basically 2/4 long and really light. The LED grid, we are using the Adafruit Neo Matrix, and due to its individually addressable LEDs, we can control the amount of power that goes towards it. So if we find that it's drawing too much, we can adjust it based on how much the dynamo generator is generating, how much load that the battery can take.
Finally, we have done testing on individual parts, and we are met with our primary design challenge, which is the ultrasonic sensor. Due to the nature of the ultrasonic sensor, since it uses sound, if the sound doesn't come back perpendicularly back to the sensor, it will sometimes have incorrect data. And so therefore, moving forward, we're looking to source different radar sensors, as well as we're going to do casing to weatherproof our system. Thank you. Any questions?
You've got some distance on your turn signals, but how about the blind spot detection? What do you think your maximum range is going to be, or your range of ranges is going to be?
To detect the objects?
Yeah, like if you had a car coming up on you, if it's 100 yards back, that's too far, but if it's a yard back, that's too short. So yeah, what kind of range?
We're looking around the range of 4 meters.
Okay.
We want to be able to detect the car within 4 meters.
Okay.
And we can quite possibly do that with the radar. The ultrasonic sensor is a little bit more finicky because past 2 meters, it kind of, due to the organic nature of cars, since it's curved surfaces, it doesn't, past 2 meters, it'll come back and it'll kind of have incorrect data. So that's why we're looking towards radars.
Okay.
Thank you for your question.
Is the blind spot detection on all the time, or only when you implement a turn signal?
The blind spot detection is on all the time.
So anytime something's coming up.
Exactly.
And then when you do a turn signal, does it also?
The turn signals will be indicated on the back LED grid, and so if there is a car in the blind spot, it will notify the rider along the LEDs and handlebars. Yes.
How many miles an hour does this power supply last before you have to go charge them?
We haven't done extensive testing on that, so,
We've just received our final parts this week, so we still have to put everything together. The final testing of how well does it go on the bike, that sort of thing, we'll be doing next semester.
Have you made any estimation on the milliamp hours that
The
you're currently running?
current battery we're using is 2,000 milliamp hours. So we'll have to do some testing, like bring the system together, see how much current it's drawing from the battery to see how long it will last. But with the generator, we're expecting it to last a little longer.
Oh, you got a generator on? Oh.
Yeah,
okay.
it'll be attached to the
Yeah.
wheel,
Yes, sir,
and
it does.
as they're riding, it'll charge the battery.
Okay.
and our parts are very power efficient as well. We have sourced very small, such as the ICBC, and they only require 5 volts, and the LED grid can use up to 1 amp, which is
That
So
would be
you-
max brightness.
Yeah, max
All
brightness.
of them on.
Yes.
What kind of dynamo generator, is that something specially made for bicycles or what?
You
Yeah,
can just
same for bicycle.
it's a 12 volt, 6 watt.
you
Yeah,
can just
6
put it
watt.
onto the bicycle, the
On the
pipe
wheel.
next to the wheel, put one end against the tire, and it'll generate.
Oh, it just rubs against the tire. It's one of those deals that.
Basically,
Yes,
Oh,
yeah.
I got it.
Yes.
So your $200 cost is probably prohibitive, and I know in mass production you can lower it, stuff
Exactly.
like that. But what is costing you? What's driving the cost?
So the reason for our cost being so high is that we're buying off the shelf components from Adafruit, for example, the LED grid and things like that. For manufacturing, it would be a lot cheaper, but again, most of the products on the market that include multiple safety features are extremely expensive. There is one bike that was a Kickstarter project that included some of these options, and the bike was over $1,000. We would like to make something cheaper for commuters and people who regularly use bikes, and for $200, surprisingly, that would be within their price range.
And this will fit on any bike.
So one thing that sounds like
One
your
last
LED
one. Go ahead.
So I'd say your LED lights, I'm assuming you guys have done some sort of distance to brightness testing or criteria you guys came up with?
Yes, we have.
You guys have already looked at that already?
Yes, we have. These are visible from 15 meters.
Okay, so
Yes,
that
sir.
is,
In daylight,
is that one of the things you guys have to deal with from a weatherproofing standpoint, or what?
So
Yes, I think we will.
we're-
It'll be
Yeah.
encased in a,
Yeah,
in its
so
own.
a lot of these, I believe these LED grids, my mistake, we were using something else for prototyping that was waterproofing, but that is another one of our main design challenges for next semester, is encasing everything in a watertight box, basically.
All right, let's thank the team.